Hello students, hope you all have seen the first module, first lecture in which I told you about real numbers, Euclid's division algorithm and a few questions based on Euclid's algorithm. How to calculate the HCF using Euclid's algorithm. This all I have already told you in the first lecture. Now today's topic is fundamental theorem of arithmetic. So what this fundamental theorem is? It says that for every composite number, means every composite number can be expressed as the product of prime numbers, and this factorization is unique. Means the factorization of the composite number is unique. What are composite numbers? The composite numbers are the numbers which has more than two factors. That is, which has the factor more than the number and 1. For example, suppose 6 can be written as 3 into 2 into 1. So the factors of 6 is other than 1 and 6, that is 3 and 2 also. So we can divide, we can say that 6 is the composite number. Now, according to the fundamental theorem, the composite number can be expressed as the product of prime numbers, and this is unique. That means apart from the order, means the order may change but the factors will be unique. This you have already studied, the prime factorization you have already studied in the previous class, how to calculate the LCM, how to calculate the HCF using prime factorization. Taking the example that suppose you have to find out the HCF and LCM of 6 and 20. 6 already you have done the prime factorization, that is 3 into 2 into 1. We can say 3 to the power 1, 2 to the power 1 and 1 to the power 1. And 20 we can factorize as 2 into 2 into 5 into 1. That means we can write it in the form of power. If we write, it will be 2 to the power 2 into 5 to the power 1 into 1 to the power 1. So on this basis, what conclusion we can take it out from here is HCF is of 6 and 20 is 2 to the power 1. HCF, you know, the highest common factor, the highest factor which is common. So here it is 2 and here it is 2, nothing else is common. So the HCF of 6 and 20 is 2 to the power 1, or you can say 2. And LCM of 6 and 20, that is 5 into 3 into 2 into 2, that is 5 to the power 1, 3 to the power 1 and 2 to the power 2 is the LCM of 6 and 20. Now if we see the conclusion, what we can say is that HCF is the product of the smallest power of each is the product of the smallest power of each common factor in the numbers. Smallest power of each common factor of the numbers. That is, you can see that the smallest power of the common factor is 2. Here it is 2 to the power 1 and here it is 2 to the power 2. The common factor is 2. So we for calculating the HCF we take the smallest power. So 2 to the power 1 is the HCF. Similarly, for LCM we can say that LCM of 6 and 20 is the product of the highest power of each prime number. Product of the highest power of each prime number. That is, the highest power of 2 was 2 to the power 2. So we have taken 2 to the power 2. 3 was the prime factor and 5. So the LCM of 6, 20 is 5 into 3 into 2 to the power 2. So this conclusion we have find out from the example that when we take out the LCM, it is the product of the highest power of each prime number. And HCF is the product of the smallest power of each common factor in the number. This you have already studied how to find out the HCF and the LCM. We will see that the LCM of 6 and 20 is 5 into 3, 45, 45 into 4, that is 120. Hmm. 4 into 3, that is 60, is the LCM of 6 and 20. And HCF of 6 and 20 is 2. So we see that from this we can find out the conclusion that the product of HCF of any two number into LCM of any two number, the HCF was 2. So 60 into 2 is 120 and 6 into 20 is also 120, is equals to the product of the given two numbers. HCF into LCM is equals to product of the given two numbers. This conclusion we have find out from here, and using this we can find out if in the questions are in this 4 quantities, that means the HCF, LCM and the two numbers. Between these 4 quantities, if any of the 3 is given, we can find out the 4th one. So we will use this for doing the questions. I will give you some examples of this. Suppose you have to, it is given that HCF of LCF of 306 and 657 is 9, is equals to 9. You have to find out the LCM. Find the LCM. So the HCF is given, the two numbers are given. So in this we will put the value HCF into LCM is equals to A into B, that is A and B are the two numbers. So in place of HCF we can put 9, then LCM we have to find out, that is, and the two numbers are 306 and 657. So from here we can calculate the LCM. LCM is equals to 306 into 657 upon 9. We can deduct it. 9 3s are 27 and then 3 carry 36 4 times. When you will do 34 into 657, you will get the answer 22338. So this is how we can calculate this. Using this formula we can calculate the LCM. Anything we can calculate. If sometimes it is given the HCF and the LCM and one number is given, you can find out the another number, and if LCM is given, the two numbers are given, you can find out the HCF. So this is one of the example based on which the questions are there in the exercise. Now I am going to do few of the questions which are of different type. The second type of question which used to come in the exam are that check whether the check whether 6 to the power n can end with the digit 0 for any natural number n. 6 to the power n है, हमें ये बताना है कि 6 to the power n में जो लास्ट डिजिट आएगा वो 0 हो सकता है या नहीं, ये हमको देखना है। ये हमें देखना है यहाँ पे। तो हम ये कह सकते हैं कि अब ये कैसे देखें, ये पता हमें कि 6 to the power n एक्सपोनेंट्स एंड पावर्स में आप लोगों ने पढ़ा होगा the law of exponent, that is a into b to the power n can be written as 8 to the power n and b to the power n. एक्सपोनेंट्स एंड पावर्स में आपने पढ़ा है। तो 6 to the power n को हम लिख सकते हैं 2 into 3 whole to the power n। इसका मतलब है 6 का एक फैक्टर 2 है, एक फैक्टर 3 है। हम अगर लास्ट में डिजिट 0 है तो लास्ट में डिजिट अगर 0 है तो इसका मतलब है कि ये डिविजिबल होना चाहिए 5 से। अब हम देखें कि 5 से डिविजिबल कब होता है, जब उसका एक फैक्टर 5 हो। 2 और 3, इसके 6 के फैक्टर्स 2 और 3 हैं। इसका मतलब है 6 हैज नो फैक्टर, 6 का कोई भी फैक्टर 5 नहीं है। 5 इज नॉट द फैक्टर. So since 5 is not the factor, that means 6 to the power n is not divisible by 5. अगर एंड में 0 आता तो इसका मतलब है वो नंबर जरूर 5 से डिविजिबल होता, बट इसका 5 एक फैक्टर है ही नहीं, इसका मतलब है 5 से ये डिविजिबल ही नहीं है. So that means we can say that therefore we can say that 6 to the power n does not end with the digit 0. Hope you all have understood the question. So you can practice the questions based on this. I am giving you some question to do. You can do it. Any question of this type, you can do it in this way. Then the other question is, you have to explain explain 7 into 11 into 13 plus 13 is a composite number. In this you can do 13 is common in both, then you can take out 13 as common and then you will solve it. You will get the factors. If you are getting the factors more than 2, that means it is a composite number. So thank you students, thank you for watching, and we will do some more questions based on this tomorrow in the next class. Thank you.